Hi everyone, it's me, Miss B, and in this video we are looking at the Unit 2, Lesson 4, Cumulative Practice Problems. And we are skipping quite a few, so you'll actually see which ones we skip from the regular curriculum a little later. So this first one, we're actually just going to do a matching question. We're matching each statement using only the information shown in the pairs of congruent triangles. So we have three different ones here, and we have three different situations. So the first situation we see says, in the two triangles, there are three pairs of congruent sides. So let's take a look. I don't see three pairs of congruent sides here, so it's not this one. I don't see any sides marked congruent here, so it's not this one. And I only see two pairs of congruent sides marked here. But it is going to be this one, and that is because you will find that they do not often mark it, but this line in the middle is going to be congruent to itself, and so that shared side is actually going to be true or congruent. So situation A is going to go with number 3, so I'm going to write A right next to this one because that's what describes it. That, or you could write a 3 next to the A, either way. For the second one, we have B. That's the two sides and the included angle. And just a side note real quick, included, this means between. So if they say it's the included angle, that means it's the angle between them. So two sides with an angle between are congruent to the other one. That definitely looks like number 1 to me. So I'm going to say that B goes with number 1, or you can say put your number 1 right next to B. And the last one, C, we're just going to double check that it works with number 2 because I don't like to make assumptions. So the two angles and the included side of one of the triangle are congruent to two angles and the included side of another. I see two angles here. The included side that they're talking about looks like it's this one right in between, and that looks like another shared side that we didn't mark congruent. And you just had to know that that should be congruent since the start and the end point are the same. So a little bit more tricky on that one. And so this one is description C. Okay. For number 2, we have some instructions to sketch some unique triangles that can be made with angle measures of 40 degrees and 100 degrees and a side length of 3. Well, if they tell me that I have an angle that's 40 and an angle that's 100, that means my third angle has to be 40 degrees because my triangle has to add up to 180. So if they give me two angles, I know the third one. And then a side length of 3. And then they're going to ask me, how do you know I've sketched all my possibilities? So let's first start by trying to make that 100-degree angle. Try to draw a little wider, I suppose. That looks like it's probably, like, this to me looks like 90, so we'll say that's like 100. And we'll describe this one as, I'll say this is my 100, and this is going to be 40 and 40. Now for a side length of 3, I have a couple options. I can choose really any of the sides here. So I'm actually going to copy this triangle because sorry, I'm copying and pasting here. Copy and paste my triangle. If I have the base side, so let's actually start with that. Let's just say this one right here in the middle is a 3. Great, it's 3. Now you might think, okay, do I have two other options? And the answer is that I don't. And that's actually because with my triangle here, if I have this left side being 3, since this is isosceles, because two of the base angles match, that means my two sides that are opposite from those are going to match no matter what. So maybe not a theorem we've discussed yet in class, but I know that I've sketched the correct triangles and the only two options, because really, if I tried to draw this other triangle with one side being 3 on the left, the triangle with a 3 on the right is actually the same exact one. So maybe my triangle here, if I want to be fair, maybe I should make this a little bit smaller so it still has those same angles. And then I can just say, oh yes, well, it is slightly smaller, so now that's 3. And maybe that 3 like actually would rotate and fit on that side now. So maybe it's like this, but either way, those are my only two possibilities. So I'm actually going to write, how do I know? Because the third angle is also 40 degrees, that means two sides will match. So the 3 is either the sides or the base. That's going to be my explanation. And then for number 3, we're actually looking at what is the absolute least amount of information we would need in order to construct a triangle that's congruent to this one. So LJ or LKJ or JKL or JLK, whichever direction you want to read those letters. What's the least amount of information? So out of all of the ways that we've learned, we've been given that you need at least 3 different pieces of information. So I'm going to list actually a couple options, but I am still going to say that I need 3 pieces of info. But there's multiple options. You could be very specific and you could say, I need to know the length of LK and KJ and JL. But I'm going to be a little bit more general here. So my options for these 3 pieces of information are going to be knowing all 3 side lengths, I could know 2 sides and the angle between, or we can say the included angle, because that would give me side angle side, and I can't actually use it with like side and angle unless that angle is a 90 degrees, and it doesn't look like this necessarily is a right triangle. So we're going to have to say 2 sides and the included angle. It doesn't matter which sides as long as we get the angle that's in between them. And then our other option is to know 2 angles and 1 side. That side can either be included or it can be one of the adjacent ones. So it doesn't have to be the side that's between the angles, it could just be next to them. So I would need 2 angles and 1 side. So a side note on this would be, I'll actually put this as a little side note. This can be, if we say the side is included, that would give us ASA, or if it is I'll just call it adjacent, which means next to, that would be A, S. And yeah, so we would need three pieces of information, but those would be our different things. So this one would be S, A, S, and this one here is S, S, S. But either way, they all require us to know three individual pieces, so the least amount of information I would need is those three. Okay, so on to question 4 and 5, which we are skipping. So now we are on to question 6. So this is the page where I said you'd see which ones are skipping. It's 4 and 5. I think we're also going to skip question 9, but it's just not at the bottom here because there is a 9th question technically on this assignment normally, but we're skipping over that one. So question 6, it says line EF is a line of symmetry for this figure. So I'm going to show you that right here. It's this line right here. EF is a line of symmetry, which means it's reflected across. So Claire says that ABEF, so ABEF is congruent to CDFE because sides AB and CD are corresponding. So they're already telling us she is incorrect. They're asking, why is she incorrect? So she says A, B, E, F, and then she says C, D, F, E. Well, first off, she's starting at angle A, and then she's starting over here at angle C, or vertex C and vertex A, point A, whichever. But because this is a line of reflection as a line of symmetry, those are not going to reflect onto each other. A would actually correspond with D, so we should be starting at D. So I am going to say her statement is incorrect because she starts, well, actually, let's not say she starts. Let's say it's out of order. It is in the wrong order. And we can say it's in the wrong order because A is not going to correspond with D. So we can say A does not correspond with D. Okay. So we want to write the correct one, which means if we're starting at A, then we're starting at D. And she goes from A to B to E to F. And she is right that A, B, and C, D correspond. But since she's going from A to B, we need to start at D and go to C. And because this is a reflection, her first naming scheme is going to be counterclockwise. And for this one, we're going to go actually clockwise. So we would say A, B, E, F is congruent to D, C, E, F. And that is our correct statement. Question 7 is another question using a reflection across FH. So we can effectively say it's pretty similar to the one above. This is a line of symmetry. It's just reflected across. And we're going to select all statements that must be true. So we're essentially just going to be checking that these are in the right order or that they're referring to the corresponding pieces. So FGH congruent to FEH. FGH, FEH. Is FGH congruent to FEH? Yes, I'm positive that those pieces correspond, so we will say yes. Also, I'm sorry if it's a little noisy in the background. Okay, so A is correct. If we have EFH congruent to GFH, let's try that one out. So EFH is congruent to GFH, and these are triangles, not angles necessarily. And yeah, with a reflection, yes, absolutely. So B is correct as well. Now we have angle HFE. So HFE, that is this angle right here in the top center corner at F. And angle FHG, that's this angle down here in the corner at point H. So not congruent because when we reflect, we should have this angle congruent to the one just right across from it instead of congruent to one on the other side. That wouldn't happen. Maybe if it was a rotation, it would be in that location. So now let's keep checking. Angle EFG congruent to EHG. So is that the one I just did? No, we said HFE and FHG. I think this one is also going to give us incorrect because, EFG goes all the way across the top. That's saying this whole angle right here. Okay. And then EHG is this angle here at the bottom. Not necessarily true, even though EFG is going to be bisected the same as EHG would. They're not necessarily congruent because it's a reflection across, and there was no guarantee that those pieces were congruent. So also not true. Now they're saying segment EH is congruent to segment FG. Those are not corresponding parts, so those are absolutely not true. And our last one here says segment GH is congruent to segment EH. Those most definitely are reflected across from each other. So yes, F is correct. So your correct choices here are A, B, and F. Okay, so moving on to question 8. This is the last question of the assignment. We are going to read through this. And this is also something being reflected, but it's a little bit of a different question. It's multiple choice. It's not select all. So when ABCD, rectangle ABCD, I should be specific, is reflected across line EF, so that's this middle line here, the image is BAC or BADC instead of ABD or ABCD. So they want to ask, how do you know that segment AD, the top, is congruent to segment BC at the bottom? Now we have a couple choices. A rectangle has two pairs of parallel sides. Any two sides of a rectangle are congruent. Corresponding parts of congruent figures are congruent, or congruent parts of congruent figures are corresponding. Well, this is definitely CPCFC, but we have two choices that actually spell out CPCFC, as you'll notice. So we need to start with corresponding. So our answer is actually going to be C, because it is important that we indicate these are corresponding first. So corresponding parts of your congruent figures are congruent, which is the difference here. And that is it for this assignment because we are skipping number 9. So thank you for joining me. And this was the Unit 2 Lesson 4 Cumulative Practice Problems for Illustrative Math Geometry.